Okay, number 2 is very similar to number 62. I have a ramp. I have an object resting on my ramp. I have a rope tied to a pulley, or attached to, passing over a pulley. And I have a mass hanging. The mass that is hanging is the 16 kilogram mass, M2. And mass 1 is resting on the ramp. The ramp is inclined at 30 degrees. And mu has a value of 0.1. Now I want to figure out the acceleration and the tension. So first thing I want to do is draw my free body diagram. So I'm going to take my M2, and I know that I have weight down and tension pulling up. Since my mass 2 is supplied to me as 16 kilograms, I'm going to multiply 16 kilograms times 9.8. And that gives me a value of 156.8 newtons. Now I want to do a free body diagram for mass 1. Mass 1 has weight 1 acting straight down. Weight 1 can be broken into components. W1y and W1x. I also have the tension pulling on mass 1, and I also have some friction. Now I have to think about which way to put my friction, which direction. W1x is going to be a smaller value than 156.8 newtons, so my whole system is going to move in this direction. So my friction needs to oppose that motion, and there is my friction. Now I'm ready to write my equations from net F equals ma. I have two bodies, so I need two equations. I have W2 minus T equals M2A. All right, for my second body, I have tension, which is positive, because I need it to cancel with the negative tension. I have negative W1x, and I have negative friction equals M1A. I'm going to add those two up. My tensions will cancel. So my total equation is W2 minus W1x minus friction equals M1 plus M2 times A. Well, I haven't figured any of these values out. I know W2 because I did value that value, and it was 156.8. W1x is going to be the sine of my angle, and I know that my ramp is at 30 degrees, so that's going to be the sine of 30 degrees times W1 is 20 kilograms times 9.8 meters per second squared. If I take a calculator and get that value, I believe that I'm going to get 98 newtons. So W1x is 98 newtons. Friction is mu times normal. Mu was given to me as 0.1. Normal force is a little different. There is my normal force. So my normal force is equal but opposite to Wy1, so I'm going to take the cosine of 30 degrees times 20 kilograms times 9.8. And if I use my trusty TI calculator, I take 0.1 times the cosine of 30 times 20 times 9.8. and I'm going to get 16.97 for my frictional force. And it's in newtons. Now I can go back up and substitute into this equation. 156.8 minus 98 minus 16.97 equals, well, my mass is added up to 36 kilograms times my acceleration. So when I do the math, I should be able to determine the acceleration. So I have 156.8 minus 98 minus 16.97. Divide that by 36, and I got the acceleration to be 1.16 meters per second squared. Now they also want to know the tension. It should not matter which equation I pick to find the tension, but I'm going to pick the easiest one. W2 minus T equals M2A. W2 is 156.8 newtons. I'm solving for tension. Mass 2 was my 16 kilograms, and it had an acceleration of 1.16. And my tension is 138.2. I'm going to stop there and pick up some papers, and I'll come back and we'll do, okay, number 3 is next. And I have 2 ropes, T1 and T2. Attach these ropes as a mass. I'm going to let it be a traffic light. The mass is 6.5 kilograms. And they need me to figure out the tension in wire 2 and the tension in wire 1. This angle here is 15 degrees. This angle here is 40 degrees. So I know that nothing is accelerating. No part of the system is accelerating, so since net F is equal to ma, I know that my net force has to be 0. So I'm going to break it into 2 parts. I want to look at it horizontally. And then I want to look at vertical. Well, T2 really has a component that acts to the right, and T1 has a component that pulls to the left. I'm going to call that one T1x, and this one is going to be T2x. And since they're my only horizontal forces, I know that their sum has to add up to 0, so T2x minus T1x is 0, and I made this be negative because it pointed to the left. Algebra 1 tells me that T2x is equal to T1x. So I'm going to say that the cosine of 40 degrees times T2 equals the cosine of 15 degrees times T1. I'm going to divide both sides by the cosine of 15 degrees. Those should cancel, so T1 is going to equal 0.79 T2. I can't go any further on the horizontal because I don't know T1 or T2. Now I want to look at the vertical. I know that T1y is right here, and it's pulling straight up against gravity. T2y is right here, and it's pulling straight up against gravity. So T1y and T2y are both acting in a positive direction. The weight of the traffic light is acting down because gravity always pulls down, and that's equal to 0 because I have no mass that's accelerating. So T1y plus T2y equals the weight of the light. So sine of 15 degrees T1 plus sine of 40 degrees T2 is equal to 6.5 kilograms times 9.8 meters per second squared. If I get my trusty little calculator out, I should be able to get my values for the sines of those angles. The sine of 15, if I punch it in the calculator, is 0.2588. But instead of T1, I'm going to substitute in 0.79 T2. Because I don't know T1, so I want to get rid of it. Sine of 40 is 0.643 times T2. And 6.5 times 9.8 is 63.7. So I now have 0.2588 times 0.79 plus 0.643. So if I do that correctly, T2 is equal to 75.1, and T1 is equal to 0.79 times T2. So T1 is going to be 59.55. Okay, that should take care of number 3. Let's move on to number 4. Number 4 is a box resting on the floor. It has a mass of 80 kilograms. There's a rope attached. It's pulling in that direction. We're going to figure out the tension. And we know that our rope makes an angle of 25 degrees with the horizontal. We know that mu is 0.1. Actually, I lied. Mu is 0.4. And we want to know the tension in the rope, and we're going to say that the acceleration of the system is 0. And basically what we want to do is we want to pull hard enough so that the friction between the box and the surface is broken. So we just barely want to set it into motion. So we're trying to figure out how much tension does it take to do that. Again, I want to look at horizontal and vertical. So let's do the vertical first. We have the weight acting down of the box, so that's 784 newtons. We have the floor pushing back up on the box, so that's our force normal. We don't know what that is. And we have Ty acting upward also. So Ty plus our force normal minus our weight is equal to 0. All right, Ty is going to be the sine of 25 degrees. T. Our force normal is going to be something we don't know. Our weight is going to be 784 newtons. So our force normal is equal to 784 newtons minus sine of 25t. Two unknowns, not so good, but they can help me solve by substitution here in a minute. Okay, the sine of 25t, if I go to my calculator, is 0.4226, so that's going to be 0.4226 times t. All right, that's as far as I can go on my vertical. Now let's look at our horizontal. I have Tx pulling to the right. I have friction to the left. And since it's not going to accelerate, I want those to be 0. So the cosine of 25 degrees T has to equal friction, which is mu times my force normal. Cosine of 25 degrees is 0.9063, so 0.9063 T is equal to 0.4 times my force normal. Well, here's my force normal, that big old expression there, 784 newtons minus oops, sorry, that was not very pretty, minus 0.4266 T. So 0.9063 T. Okay, now I have to distribute that 0.4. So I'm going to multiply 0.4 times 784, and that's going to give me 313.6 newtons. Minus, I'm going to multiply 0.4 times 0.4266, and I believe I'm going to get 0.1609 T. I need to get this T over to here. So I'm going to do that by adding. Those will cancel. So that's going to give me 1.067 T. 1.067 T equals 313.6 newtons. I'm going to divide both sides by 1.067. If I do that, then my tension should be 313.6 divided by 1.067, and I got 293.85. Now yours may be a little different depending on where you rounded, but you should still get a value close to mine. So that took care of number 4. Now number 5 and number 6 are very similar. I'm going to work number 5. I'll give you the answers to 6, but I really don't think I need to repeat the process because they're so similar. Okay, if you look at number 5, it looks like I have an angle, a horizontal. This is tension C, tension B, and then there's a knot tied here, and there's a rope with 100 Newton objects hanging from it. So that's my tension A. Now, if I have 100 newtons straight down, then the tension in A must also be 100 newtons. All right, so I have tension A being 100 newtons. Now, if you were to look at C, it really can be resolved into a CY and a CX. CY must also be 100 newtons because it's my only vertical force. So if I know that this angle here is 30, I can say that the sine of 30 degrees is equal to CY over the hypotenuse, or C is equal to 100 newtons divided by the sine of 30. The sine of 30 happens to be 1/2, so 100 divided by 1/2 is 200 newtons. Then finally, CX pulling to the left has to balance B pulling to the right. So I can say that the cosine of 30 degrees times 200 newtons must equal B. The cosine of 30 degrees is 0.866. If I multiply 0.866 by 200, I should get 173.2 newtons as my value for B. So here's B, here's C, and here's A. For number 6, the correct answers, we're looking for the tension, the force, and C. So the tension, I got a value of 357.66 newtons. I got F to have a value of 296.5 newtons. and C had a tension of 200 newtons. Alright, number 7 is kind of long. So when you look at number 7, you have 3 things going on. You have a weight that's hanging in the air freely. I'll call that W1. And there's a rope tied to it. I'll call that tension 1. There's a block resting on the flat surface of the ramp. It has weight 2. It has a force normal, and I'm going to call that force normal 2. It has the tension of 1. And there's some friction. Now I know to point my friction in that direction because it has to oppose the motion. There's also a rope attached here. I'm going to call that tension 2. Finally, on the ramp, I have a block that's resting. It has a weight. We'll call that W3. It has the Y component to the weight. It has the X component to the weight. It has a normal force. Rather poorly drawn, but there's the normal force. And again, it has friction. And friction is going to oppose the motion, so it's going to be down the ramp because this whole block is slipping up, being pulled up the ramp. This is being pulled to the left, and this one is falling down. I know my acceleration is 2. And I believe that I'm asked to find T1, T2, and mu. So now I want to write some equations. So I'm going to start with body 1, and I'm going to say W1 minus T1 equals M1A. W1 is 98 newtons. T1 I don't know. Mass 1 is 10 kilograms. And positive 2 meters per second squared is my acceleration. So T1 is simply 78 newtons. Not very hard to get, but that's one of the answers they want. Alright, if I look at this system here and try to write an equation for it, I'm going to have T1, which needs to be positive, and T2 negative, and friction 2 negative is equal to, and I didn't give you this value, but I'm going to go with 5 kilograms. Let me see if I can move this toolbar. And it's accelerating at 2 meters per second squared. T1 was 78 newtons. Tension 2 we haven't solved for yet. Friction 2 is mu, which I don't know, times my normal force. In this case, my normal force is my weight. So 5 times 9.8. And then 5 times 2 gives me 10 newtons there. So I have some unknowns that I don't know anything about. So I'm going to leave that one alone for now and go up to the third one. The third one has Wx down the ramp, friction down the ramp, and tension 2 up the ramp. So since tension 2 is negative in the second equation, I need to make this tension 2 be positive, and my friction negative, and my Wx negative, because they're going down the ramp. So I have tension 2 minus W3x minus friction 3 is equal to mass 3 times acceleration. Tension 2, I don't know what it is. W3x is going to be the sine of the angle. Oops, that looks kind of sloppy. Let's see if we can pick that up and make it look a bit nicer. So tension 2 is going to be sine of, okay, that ramp angle was given to me, and I don't have it. So let me pause for a minute and find the original. So that's going to be the sine of 25 degrees. The mass that I'm looking for there looks like 3 kilograms. 9.8, can't forget that, minus my friction, which is mu times my normal force, which is going to be kind of tricky. It's going to be the cosine of 25 degrees times 3 kilograms times 9.8. And I need to be able to go over that way. So let's see. What if I just brought the M3A over here? 3 kilograms. Oops. 3 kilograms times 2 meters per second squared. So now I have 6 newtons equals T2 minus, okay, I can do the sine of 25 times 3 times 9.8. So sine of 25 times 3 times 9.8 gives me 12.42. So that value is going to be 12.42. Mu, still don't know, but I can go ahead and multiply the cosine of 25 times 3 kilograms times 9.8 meters per second squared, and I get 26.65 right there. So I'll just put that in a parentheses. So now I'm going to take my third equation and add my second one to it. So I'm going to write down the second one here. It's 10 newtons equals 78 newtons negative T2 minus mu times 49 newtons. Well, if I set it up correctly and I go to add those equations now, my T2 should cancel out because one should be positive and one should be negative. So now I have 16 newtons equals 78 newtons minus 12.42 newtons minus mu times 26.65 minus mu times 49. Now I only have one unknown left. So I'm going to say 16 newtons. Now 78 minus 12.42 should be easy enough to get on my calculator. So I'm going to take 78 minus 12.42 and I'm going to get 65.58. And then I have the same unknown on both of these, so basically I'm going to add 49 to 26.65. So that gives me mu times 75.65. I need to get this over to the other side. So those cancel. So 16 minus 65.58 gives me a negative 49.58. And it's okay that it's negative because I have a negative on the right-hand side, so really I'm dealing with the positive. Then divide by negative 75.65 on both sides. This cancels. So if I did it correctly, I should get a positive value for mu. And I got 0.655 for my mu. So I've got T1, I've got my mu, now I need to get my T2. So I'm going to go back to one of my equations. I think the easiest one to deal with would be this one right here, T2 minus W3X. Well, we said W3X was 12.42 minus mu times 26.65. And that has to equal 6 newtons. And if you're lost, I'm taking that equation right there and just rewriting it to solve for T2. If I do that correctly, my T2 should be 35.9 newtons. And I believe I have solved number 7 for you. So I'm going to stop, see if I have any luck posting this, and hoping that you're going to study.